Hello everyone, and how are you? Welcome to Activity Hub. As we are going through C tutorials, this is the third video of the course, and today we are going to learn some basic concepts that will help us to write a basic C program. Okay. So firstly, comments. Comments are a component of code which enhance the readability. They are not the code that compile, but they just describe what a block of code is doing. They don't have anything to do with compilation. And there are two kinds of comments: multi-line comments and single-line comments. Multi-line comments start with a forward slash and an asterisk and end with an asterisk and a forward slash. And these comments can be extended up to an infinite number of lines. These have no limit. But while coming to single line comments, they start with two forward slashes, and they are only limited to a single line. So let's go into our IDE Visual Studio Code and know how multi-line comments and single line comments work. So here, as you saw, it started with a forward slash and an asterisk, and it ended with an asterisk and a forward slash. And anything you put inside inside these both things will be a comment. And I generally use this to mention three things at the top: my name, the purpose of the file, and the date. As we are doing it for practice purpose, let's name it as practice. And finally the date. Six 2021. But while coming to single line comments, they start with two forward slashes, but they are only limited to a single line. For example, let's write hi, hello, anything, and only what you type here will be in the comment. In the next section, if you go to the next line, what you type here will not be recorded as a comment, it will be recorded as something else. So the actual code will start from the next line. So it is only limited to one line. Next, next we have to know what are preprocessor directives. Preprocessor directives are something that are handled by the preprocessor and not by the compiler. Preprocessor is nothing but which runs before the compilation of the code. That means these preprocessor directives are executed before the compilation. That means the preprocessor, it's like the preprocessor saying, hey compiler, wait, I have to do this before you compile the code. And they start with a pound symbol, hashtag. And some of the common preprocessors are include, which are used to include the files, used to define constants, if that is used for condition compilation, etc. And this preprocessor directive include is the main thing that you have to concentrate here. The function of this directive is to include an external header file which contains the required function prototype. Function prototypes are nothing but the declaration of functions. You will study in detail about functions and their prototypes in the later part of the course, but for now understand this. Includes a external header file. So sorry. So what is a header file? Header file is a place where some of the function prototypes are stored, and this end with a .h extension, and some of the common header files are stdio.h, stdlb.h, stdbool.h, etc. The most commonly used header file is stdio.h, standard input output, and these header files can be utilized by including them in the source file with the help of include preprocessor directive. The syntax to include a header file is include stdio.h. So let's clear this code. Include the preprocessor directive and stdio.h. This stdio.h contains some of the most important and common functions. And remember one thing, when you are using preprocessor, at the end of every statement you don't need to use comma. There is no need to use semicolon, but for others you have to. And before going into the next part of the course, I have to say one thing for you. There is a function called main function, and in that function itself all the code executes. Outside that function they are just declared, or they are just doing something, but inside the main function itself all the code is written, all the main code which have to be executed. So how do you write a main function? First you have to type int, then main, then a bracket, and leave that bracket empty, and take a flower bracket, and at the end write return 0. And this is the common main routine, and this whole thing is present for any source file you see in the C. Okay, and between in this place itself you should write in this place itself you should write the code which you want to execute. So let's move to the next slide. The next slide is about printing output. There are some times when you want to display some output to the screen in a program. That is where the printf function comes into play, and this function is declared in the header file standard io.h, and this prints out any sequence of characters that are declared inside the double quotes, nothing but these double quotes. This can also print out some variables with the help of format specifiers, and the format specifiers will start with the percent symbol. Some common format specifiers are %f, %d, so on. And if you don't understand these two lines, don't worry guys, in the later part of the video you will understand what are variables, what are format specifiers in detail. So up until this point what you have to concentrate is printf is a function which is declared in standard io.h, and anything that is inside these double quotes inside the bracket will be printed out. So let's go to our IDE Visual Studio Code and test this. So I wrote this my name inside these double quotes. Let's see if this prints or not. Sorry. Just a minute. See, it printed out Niket. It printed out Niket. And anything you put inside these double quotes, like if you write hello, it will print out hello. So the example for format specifiers I will show in the later part of the video, okay? So let's move to the next slide. Reading input from the terminal. Every time while you are printing output, every time you print the output, you might not know what information you are printing out, or every time you might not have the information you want. Sometimes you want the user to enter the information. And that is where you use scanf function. And the scanf function is the syntax for scanf function is this, and inside these double quotes you have to use the format specifier for suitable data type, and you have to write the name of the variable after a comma, and the variable should always be along with the ampersand symbol. And if you forget the ampersand symbol, it may lead to undefined behavior. You might not know what's happening. And at the end there is a semicolon. So let's go to the IDE and see how it works. So here you might not understand some of the code, but don't worry, after the completion of video you will understand everything what I wrote here. So don't worry guys, that's it. So let's create a variable called x, and let's do some scanf. %d as okay, ampersand the name of the variable x. You might not understand what this x is and what is this format specifier, why are we using this, and what is this ampersand, what is this x, etc, etc. Don't worry guys, and just let's build it. See, it asks for an input, and if you know if the you might get a doubt that is the input stored properly or not. Let me show you that by printing out the value of the x. See 5. And this one, the backward slash new n is there, right? It is used to print a new line inside. For example, let me show you that. Let's print just n, and if I compile that, when I run the code, it prints a new line. There is nothing here, a new line, just a new line, that's it. So let's move to the PowerPoint presentation. So we are moving into the most important section of this video, that is data types. We will discuss about various variables, constant, and the types of data they can store. So firstly, variables. Variables are something that can store data, and their value can be changed from time to time. A variable can be of multiple types, like types of data like int, float, double, etc. And remember one thing, a variable name should always start with a letter or an underscore and can be followed with any sequence of characters, rather be it a symbol, number, etc. But this symbol, dollar symbol, is not allowed in the variables. And embedded space between the variable's name is not allowed. And use meaningful names for better readability. Every time when you declare a variable, it should not be like you write a comment to describe what the variable is. Hence, write the variable name in such a manner that the variable name itself describes its function. For example, if you want to print out if you want to store a sum of two integers, then declare the variable name as sum. If you want to store a perimeter or area of something, of a shape or anything else, declare the variable name as area, perimeter, etc. So this enhances your readability. And some of the basic data types are int data type, which is used for storing integer values, float data type, which is used for storing decimal values, double data type, which is used for storing also decimal values, but it can store more data. Card or chart data type is used to store any character like a letter or a symbol, anything, but it should always be inside the single quotes, the data, not the variable, the data. So the format to write declare a variable is, first write the name of the type of the variable, rather be it int, float, double, char, etc. And next comes the name of the variable, and write the name without any embedded spaces, and end the statement with a semicolon. So let's go into our IDE Visual Studio Code, and now let me declare some basic variables. Like, let's create a variable called x of type int. Let's create a variable called y of type float, a double variable z, and a char variable m. Oh, sorry. Assigning and initializing variables. So in the IDE we created some variables, right? And they are of no use if we don't provide a value for them. Hence we have to either initialize or assign a value for them. Initializing the value means giving the variable a value at the time of declaration. For example, int x equal 5 says that equals 5. At the time of the declaration, you can give the variable of this value, and even at the later part of the variable you can give this, like x is equal to 15. No need this in, just write the name of the variable equals the value. It is always a good practice to initialize values, because it is a cleaner approach. Because I would suggest to initialize all the values of all the variables to 0 at the time of their declaration, because it is a cleaner approach, so that it don't cause any problems. So let's go and assign some values to those variables we have created. So let everything be 0. And remember one thing, the value of the char data type should always be in double quotes. It can also be in some number, but these things, right, when you put them in the double quotes, they are called ASCII values, and they are called characters, and all the characters have some ASCII values as in the form of integers. So if you for the 0 character, the ASCII value is 0. For 1 character, the ASCII value is 1, something like that, and hence always put them in double quotes. See, for example, if you try to give x, it will ask what is it. That there is a variable called x. Let's try f, and it says that identifier f is undefined. So if you try to put this in double quotes, single quotes, there will be no problem. And one more thing, never try to put them in double quotes. The double quotes will only work for character arrays, not for character variables. You will study about arrays in the later part of the course, but for now understand that you have to put the variables value in single quotes of character variables. So as you can see, now the values are printed, and see F0000. The next data type that we are going to study is the BOOL data type. The BOOL or underscore BOOL is used for logical evaluations, and the underscore BOOL can store two values, 0 or 1. 1 if the evaluation is true, and 0 if it's false. And the BOOL is an alternative for underscore BOOL. The BOOL is an alternative for underscore BOOL, and it is declared in std_bool.h header file, the alternative, the BOOL one. And this data type can have two values, true and false, so that it is more readable. So let's go into the IDE. I would always suggest to use the BOOL rather than underscore BOOL. So let's include that, std_bool. As that is declared in std_bool, we have to include to access that BOOL data type. So let's declare something like this: BOOL mn is equal to false, or it is equal to true, etc. So for now, let it be like that. For now. We don't see what kind of logical evaluations can be done, because to do those evaluations we need logical operators, and about logical operators we are going to talk in the next video. So for now, know that BOOL is used for logical evaluations. The next one is Enum data type. Enum data type is used when you want to store a value for the variable among some fixed options. Like here, the syntax is, first you have to write enum and write like something like my color, and in the flower bracket you have to write the values which you want. If you want to assign red, if you want to assign blue, if you want to assign green, and other than these three, no other values can be assigned to the enum data type. And then in the next step, enum, you should write enum my color, and this, and So this created a new data type. Enum mycolor is a new data type, and for this only three types of values can be assigned: red, blue and green. And to this enum mycolor data type we declared a variable of your color which can store either red or blue or green, and no other color can be stored here. And when you try to print all these values, if for the first one mentioned in the list, like if you want to go for red, if you assign red to your color and try to print it, it's going to print 0, and for the blue it's going to print 1, and for the next one it is going to print 2, etc. So let's go into IDE Visual Studio Code and try this. Let's declare like enum mycolor red, blue and green. Enum mycolor your color and see your color. If we try to assign it red and print it out, printf %d, because okay, let me explain it later about %d. Your color just a minute. Zero, you saw 0, and if I try to assign green, two. So this is all about variables and data types. So this source file is there, right? The main aim for today in this source file is we have to write a C program that can calculate the area and perimeter of a rectangle. So let's declare proper variables for those. So firstly, int length, a variable for length of rectangle. I will use underscore to make sure that I can easily know the difference between words, but you can also use something like camel case, something like this. Before every word, the first letter of every word should be capital so that you can easily know, but I would prefer underscore. You can prefer either of them. Is equal to 0. Int width of rectangle, 1 for width, is equal to 0. Int perimeter of rectangle is equal to 0, and int area of rectangle is equal to 0. So let's move to the next slide. Before using printf and scanf, let's know about constants. Constants are just like variables. They too store data, but their values cannot be changed after their declaration. And if you try to change the value, the compiler will give you a compiler warning. There are two ways to declare a constant. One is to use the preprocessor directive define, and second one is to use a const keyword. So firstly, define. Define is a preprocessor directive that helps you to declare a constant. But here you cannot specify the type of data that you have to store. For example, something like pound define pi 22 by 7. The value of 22 by 7, that is our pi 3.14, will be stored in a constant called pi. The first part is the define preprocessor directive, and the second one is the name of the constant, and the third one is the value of the constant. The const keyword will also help you to declare a constant, but here you can specify the type of data you want to store. For example, const double pi 22 by 7. You can even add const float pi 22 by 7, const int pi 22 by 7. The first const keyword, the const keyword is the keyword and is the keyword that says that the declaration is for a constant, not for a variable, and remaining is as same as the thing you do for the variables, as declaration for the variables. So let's go to the Visual Studio Code, and here let me declare a constant with define preprocessor. Pi, rather than doing it 22 by 7, I will declare it 3.14. And let me declare a constant here of type double pi is equal to 3.14. And let's print out the values. Before printing out the values, I have to say one thing. You cannot print out this pi directly, so you have to store the value of this pi in a separate variable, and then you have to print it out. For example, let me create another variable of double, which is pi copy is equal to pi. So let's print out the values. %lf new line, %lf and length of rectangle. Sorry. Pi and pi copy. So let's save this and run it. 3.14000, and to limit this, let me add dot. Hmm. 3.14. Format specifiers. There are times when you want to display, as we said, the scanf. Sometimes we want the user to enter the information, and we store that information in a variable. And what if sometimes you don't know what is the value of that variable, and so at that point of time you don't know what is the value of the variable. Hence you have to print out the variable's value, but you don't know what is the value. How do you print? So basically you have to print out the value of the variable. So how do you do that? With the help of format specifiers. They start with a % symbol and always are used inside the double quotes. They are used in some common functions like printf, scanf, and so on. In printf function, there will be in the double quotes you use place %d, and after the comma you place %x, and in the scanf %d, and I forgot to write the ampersand, but please don't forget to write the ampersand because it leads to undefined behavior. So what is this %d, %l? I used in the IDE I used %lf. Here I'm saying %d. So what are these things? Let's know. %d is the format specifier that is used to print out or take input that is used for integer values or even boolean values, because they can only print out 1 and 0. Even for enum values, like right when I was printing enum, I used %d and %f for floats, %lf for double values, %c for character, %p for address of mainly address of variables. Like while you're working with pointers, you need to print out some address. Sorry. And address and %z for size of operator. We will know about what is the address in the later part of the course, and size of operator about size of operator in the next video. Okay. So here, as these both are doubles, I used %lf to print them. And firstly, the first format specifier you use will be will print out the value of the first variable you write here after putting a comma, and after putting a comma after that variable, the second variable you write will be printed by the second format specifier you mentioned. And I said %lf, and what is this? You might be wondering, what is this .2? This .2 is special. It says that how many values should, how many digits should be printed after the decimal. For example, when I change this to 3, it printed out 3.14 here, right? Before it printed out 3.14, it will print out 3.140. Let me save it and compile it. Sorry, 3.140. and if I change it to something like 10 and 15, and you see they print it out. So as I don't want to print those zeros, I want to only print the 3.14. I wrote 2, so this prints out only after the 3, after the decimal point, it prints out only 2 values, 3.14. So now we understood the printf and scanf functions properly. So now to calculate the area and perimeter of a rectangle, let's use some common printf and scanf functions. Firstly, we will write a printf function which says that enter the length. We are taking input from the user, the length and breadth. Enter the length of the rectangle. Scanf %d because we are using integer. Length of a rectangle is an integer. And 1 minute, let's clear this defined by and all these things. Length of rectangle and printf enter the width of the rectangle. And this one should be for width of rectangle. That's it. So let's compile it and see whether our code works properly or not. And I will enter 5 centimeter. The values are in 5 and 6 centimeter. So the next step is to, in this source file, is to calculate the width and length of the rectangle, right? For example, the calculating the area and perimeter. So to calculate the area and perimeter, we need to do some operations, like 2 into L plus B is the formula for perimeter, L into B is for area. So we have to perform some operations on it. So before performing those operations, we should know how to perform what are operators in C. So So operators are something which help you to perform some operations. Like addition operator is used to perform addition operation, like adding two variables or more than that, x plus y. Subtraction operator is used to subtract two variables. Multiplication operator is used to multiply two variables. Instead of multiplication symbol, here we use asterisk. This division operator is used for dividing them. And the modulus operator is used when modulus operator is used when you divide two variables. Sometimes you are left with a remainder, right? For example, if 18 is divided with 5, you are left with a remainder of 3, and when you do the modulus operator, it returns you the remainder, like it returns you the remainder basically. So let's go into our IDE Visual Studio Code. So here, let me perform some operations. Let me declare a variable called sum of int type, and let me add length of rectangle plus width of rectangle. Int difference is equal to length of rectangle minus width of rectangle. An int of product, which is equal to length of rectangle into width of rectangle. Int quotient, which is equal to length of rectangle by width of rectangle. And finally, int remainder, the modulus operator, length of rectangle modulus operator, width of rectangle. This basically returns the remainder. So let's print out all these variables. Firstly, %d, %t. Okay, let me write some meaningfully. Sum is %d, new line. Difference is %t. Product is %t. Quotient is %lf, new line, and remainder is %t. Sum, difference, product, quotient, remainder. Okay. Oh, sorry, I wrote the spelling of remainder wrong. Remainder. So as you saw here, after writing all the code, let's write it like 5.00, the product, the sum, and the remainder is 0 because it divides completely. So as we know now how to do sum, difference, and all these basic operations, let's find out the perimeter. So the perimeter of the area is, of the rectangle is 2l plus b, right? So 2 into length of rectangle plus width of rectangle. And let's also write the area formula, length of rectangle into width of rectangle. So let's print out these. Printf the perimeter of the given rectangle is %d. Length of rectangle. Hey, sorry. It's the perimeter of rectangle. Perimeter of rectangle and the area of the given rectangle is %d. Let's print area of rectangle. So let's see how our C program works. Okay, the first one, let's give her some 20 centimeter for length, some 25 centimeter, and 90 is the perimeter of the rectangle. 20, 20, 40, 25, 25, 50, so finally 90, and 500, 25 into 20, 25 tens are 250, 250 into 2, 500. So yeah, we're good to go. That our first C program worked well. You can even try something like this. So never ever try something weird things like when they ask for a value, don't type something like hello, because it leads into the some undefined behavior. Or even sometimes hi again, sometimes a core file will generate. So never try something weird like this. Even my system crashed once. So that is it for today, and here we are on to the last slide that describes the challenge for today for you, and this is a challenge that should be done by you. So the challenge is write a basic C program that can calculate the area of a circle and the circumference. So for the information about radius and diameter length, use scanf and ask the user to enter them, and you can create a constant called pi, which that is 3.14 or 22/7. I would suggest 3.14 for calculating the circumference and the area, and finally print out the values of those variables using printf. So you have to create a couple of variables for radius or for diameter, and next for the circumference one, and one for area of a circle, and finally printing out all of them. So that's it for today guys. It was a wonderful session with you, and thank you so much for all your love and support. And you can mail me the code of the challenge at the Gmail, at our Gmail, and the Gmail will be given in the description below. Check out that once, and thank you guys. It was a wonderful session with you. Bye.